Okay, quickly, I'm going to start every class like this for the next week at least. If you are struggling, please come in here during my free periods, 3, 5, 6, or after school. Okay, if you're struggling and need some help, probably might be a good idea. You saw your Unit 3 test grade on Aspen. All right, for some of you it wasn't pretty, and you know that. And there's only 2 more opportunities left. That's the unfortunate thing. You got your quiz next Wednesday. On Unit 4. And then we have this cumulative 1 quiz, which I just want to remind you about again. And I also know there was people who weren't here yesterday. On Wednesday, November 10th, we are going to have a 20-question multiple choice. All multiple choice, no show work. It's just all multiple choice, right or wrong. On Wednesday, November 10th, that's going to cover everything we've done so far this quarter. All right, you have to answer 15. Anything above 15 right, I tack on 2 extra points for however many you got right above 15. Okay, so out of the 20 questions, you have to answer 15 of them. All right, and again, anything above 15 right is just added on to your total. So it's out of 30. All right, soon, I don't know when, but I'll release 40 practice questions on formative. That's the other big piece too. Please remember, this is going to be on formative, so you're going to need stylus Chromebooks that day. Okay, I'm not going to give out paper copies. And this is the way every geometry AB student is taking it. All right, so you guys have no disadvantage or advantage taking this. Everyone's taking it on formative, same question, same everything. Okay, same review. Okay, nothing extra or nothing I'm hiding from you. All right, so you guys got 2 more opportunities to really raise your grade if you're not liking your grade right now. All right, you got next Wednesday, a week from today, quiz number 1 in this unit, and then you got the cumulative quiz the Wednesday after. All righty? Questions, comments, concerns there? Just wanted to review that again. And come on in and get some extra help. All right, let's move on. You guys had some work out of the book last night. Hopefully you checked your answers on Classroom and you have questions for me ready to go because maybe they didn't match up. Any questions that you want to ask from last night's isosceles, equilateral, scalene, acute, obtuse, right triangle, business? Anything we want to ask? Now's the time. Romeo, let's go.
Number 44.
Okay, 44, everyone, take a look. Okay, 44 is pretty big here, Romeo, so you're going to have to give me some direction because it was a graphing problem. I know we did one in the notes yesterday as well. You're going to have to give me some direction on where you need help on.
I'm doing like the distance for xz.
Okay, xz. So again, we used this distance formula yesterday in class. X2 minus x1 squared plus y2 minus y1 squared. So if you want xz, first I look at x and z and take the x coordinates and subtract them. So 9 and 7 subtracted, squared, plus 1 minus 6, the y coordinates subtracted, squared. So now here I have 2 squared, which is 4. Here I have negative 5 squared, which is 25. Xz is the square root of 29. And yes, I know I asked you to break it down if possible. But if you look at the perfect squares we went over yesterday, 4 does not go into 29. 9 does not. 16 does not. 25 does not. I'm not going to go any further because it's bigger than 29. All right, none of those go into 29 evenly, so that is simplified. Xz is the square root of 29. And then I do the same exact thing for xy and yz. I don't know if anybody graphed it, but did I need to use distance formula on yz if I graphed it? What could I have just done instead of using distance formula? Anybody? What could I have just done to find the length of yz here? Count, right? Just count because it's a horizontal line. 1, 2, 3, 4. Done. If you use distance, you should have got 4 as well. But all right, other questions from here? Anything else we got to cover? Ask away. Jackson, what do you got?
51.
Okay, 51. I got a triangle. MNP. Are we okay labeling a triangle? MNP are the 3 vertices, the corners here. M and P. In any order, doesn't matter. MN and NP are congruent. So I'm going to put my congruent marks on there. MN is 2 less than 5 times x. How do I write that? 2 less than 5 times x. How do I label MN if it's 2 less than 5 times X? Let me get to some people who were here yesterday. 13 in the house. 13, Calum, go ahead. 2 less than 5 times X.
5x minus 2.
5X minus 2, so that's MN. NP, 7 more than 2 times X. 7 more than 2 times X. How am I labeling that side? 1, George, how am I labeling that side?
2x plus 7.
2X plus 7. And then it throws in PM, which is 2 more than 3 times X. 2 more than 3 times X. What are the only two I'm concerned about in this problem? Romeo, what are the only two I'm concerned about?
5x minus 2 and 2x plus 7.
Yeah, those are the ones that are congruent to each other. So I say 5x minus 2 is equal to 2x plus 7. I don't use it. I showed you this yesterday. Just because I give you all 3 sides doesn't mean you have to use all 3 sides. Solve for x. X is 3. And then I take 3, plug it in, plug it in, plug it in. Okay? Other questions here? Anything else? Okay, can I see your work, please? Hopefully it's a little deep. Hopefully you're showing a lot of work here today. Okay, showing a lot of work. I should see some distance formulas. Definitely work on 51 and 52. While I'm coming around, if you have a minute. Give you guys a minute here to get set up and organized and focused. We're going to talk about the angles now in a triangle. Inside and then angles outside a triangle. And that's today's topic. All the angles inside, all the angles outside. I think we discussed this yesterday. What do all the angles add up to in a triangle? 180. Okay, that basically, I gave it a theorem. I gave it a name. That's the triangle angle sum theorem. That just says, hey, all interior angles of a triangle add to 180. That's what that says. Just giving it a fancy name. That's a fact we already know. Okay? All of them add to 180. We good? Okay, I'm going to start pretty basic today, and hopefully you guys can help me out. Big thing here first is making sure you can draw your own diagram. All right, so I have a triangle. Everyone sees the 3 angles in the triangle. 2x, x plus 10, and then 3x minus 10. Those are my 3 angles. So let's give me a triangle right now. Go ahead. Draw your own triangle. And put those 3 angles in there. So at one, and I don't care where they are, it doesn't matter. So at one of the angles should be 2x. Another angle should be x plus 10. And the third angle should be 3x minus 10. Put them anywhere you want. Okay, can you help me find x now? Can you help me find x? Use the one in the back, Carter. It's much better on the near the windowsill there. Okay, can you help me an equation to find x? Excuse me. 23. Lucy, ready? What do all 3 angles add up to here? 180. So write that for me here. 2x plus x plus 10 plus 3x minus 10. Yep, that'll give me a $1.80. All right, all 3 angles add to 180. Done. Now go ahead and solve. Combine your like terms, move everything over. Hopefully this isn't an issue. When you're ready, what do you have for the value of x here? Value of x, 4. Via, when you're ready.
Is x equal to 30?
Yep, x equals 30. Good work. All right, let's keep building on that. Now find me each angle measure. All right, find me each angle measure. So take 30, plug it back in, and give me the 3 angles in the triangle. How many degrees? And hopefully the three angles you give me do add to 180. So when we're ready here, 2, 1, when we're ready. There's 21, I already have one. 21, Scott, when you're ready, take your time.
So x plus 10, and that's 40, and then 2x is 60, and then 3x minus 10 is 80.
There you go. 40, 60, and 80 degrees. They all add up to 180. Looks good. All right, now we're going to have to look back in your notes if you forget. If I have all three of those angles, what type of triangle do I have? Okay, I got a 40, a 60, and an 80. What type of triangle do I have? Remember, name it by its angles. I don't know anything about the sides yet. Just name it by its angles. 40, 60, and 80. If those are my three angles, I can call this triangle what? 16? 16, Carter? Okay, that's by, you are correct, but that's by its sides.
Oh.
All right, all three angles are less than 90, so I can call it acute. Perfect. All right, so this is an acute triangle because all three angles are less than 90. Perfect. Good job, guys. Good job. Any issues? Anything you want to ask? Yes, you could call it. I would accept scaling too, because if all three angles are equal, that means all three sides are unequal as well. Unequal. All right. Let's advance our knowledge here a little bit. Big thing. Can you draw the diagram for me here? Triangle ABC. Here you go. Throw it up here. Triangle ABC. Order does not matter. The vertices don't matter where they go. Put them wherever. All right, fill in angle A and C for me. A is 40, C is 30. Fill it in. Fill it in, because we got to draw more items there. 40 and 30. So 40 here, 30 here for me. All right, everyone ready? I'm going to draw on line segment CD now. All right, where CD is going to bisect C, and D is a point on AB. So put a point on AB. We'll call it D, and draw in segment CD. And you are now, ready? As you're drawing that in, you are bisecting angle C. So hopefully you know what's happening right there. Maybe you can add more degree measures onto your diagram. If I know this line right here is bisecting C. Maybe. Did anybody put anything on both sides of that line at 30 degrees instead? What could I put on each side now, right? And I'm specifically talking here and here. What degree measures can I put on there? Let's go. Oh, 17. What can I put on each side? Correct. 15 degrees here, 15 degrees here, because I know what bisects means. Vocab, vocab, vocab. All right, you guys ready to? Well, first, hold on. Let's not. I don't want to answer the questions yet. I got to make this point clear. Everyone sees three triangles in this diagram? Sees three, right? Each one has 180 degrees. Just because this triangle DAC is in the big one doesn't mean it has less than 180. It has 180 degrees. So does this one, BDC. If it's a triangle, it's got 180 degrees. I don't care if it's a triangle within a triangle. They all have 180. Please remember that. All right, angle B. How many degrees in angle B? Take a peek. Angle B, how many degrees? And remember what I started you out with. I started you out with A and C. How many degrees in angle B? Come on, dig deep. Find a way. 20. How'd you get 110? That's correct.
Angle A is 40, angle C is 30, and that equals 70, and we're missing 110.
How many degrees in triangle ABC? 180. I know two of them. Subtract them from 180, $110. And I always recommend to students, especially in a multi-part question like this, A through D, when you find an answer, put it in your diagram. You never know. It may help you down the road. All right, good job on A. B, ACD. We already did that, right? ACD, we already put 15 down. Emma gave us that one, so 15. All right, back to you now. ADC. Look at your diagram. How can I find how many degrees in ADC? ADC. Think about it. Take your time. Take a breath. ADC. 16. Thoughts? 16. Carter? 125. Good work. Here's what Carter said. Look at triangle ADC. There's 180 degrees, and I already know one angle is 40, the other angle is 15. So the third angle's got to add up to 180. 125. Good work. And then BDC, finally. BDC, the only angle I don't have here. BDC. Thoughts? BDC? 13? Callum? Take your time when you're ready. 55. Good work. Couple ways. You could have said it was supplementary with 125 because these are linear pairs. Or you could have said, hey, use this triangle right here. I already have 110 and 15. Subtract it from 180. Good job. Anybody else? Issues? All right, let's keep grinding. Let's keep grinding. Let's get up to this geometry AB level. All right, last one for interior angles. Still triangle ABC. We like those vertices, right? ABC. You guys have what? 2 to 7 on yours, right? Okay, yeah, I gotta change mine. It was 2 to 5. 2 to 7. Measure of angle C is 72. All right, I can plop a 72 in there. Now, what's the deal with A and B being a ratio of 2 to 7? We've done a couple of these problems before where angles have been in ratios. Anybody, instead of putting a 2 and a 7 on A and B, that doesn't make sense. What have we been doing here, Lisa? We've been putting x's with our ratios, right? So instead of putting a 2 at angle A, I'm going to put 2x. And then at B, I'm going to put a 7x. What can I do with all three of these angles? 8.
You can add them all.
Molly? There you go. Good job, Molly. 2x, 7x, 72, 180 degrees. Good work. All right, go ahead. All right, your value of x on this one. Your value of x. 10? 12. Thank you, Josh. Good work. I'm trying to break this habit with a few of you. X doesn't mean I'm done with the problem. I got to go back and say, hey, oh, I need to find the measure of each angle. So we're taking 12, plugging it back in. What's A? And what's B after I plug it in? 15?
84 and 24.
Molly, good. 84 and 24. Good. So 84 for angle B, 84 degrees, 24 degrees for angle A. Good work, guys. Anything? I think we all have a good feeling and understanding for interior angles. Now, this may be a little awkward and uncomfortable because now we're going to talk about what about an angle outside the triangle now. Okay, an angle outside. That's what we call an exterior angle. All right, an angle can be formed on the outside. Just extend one side and you got an exterior angle. All right, so you take a triangle, extend one side a little further, and you got an exterior angle. I have 3 of them on my diagram right here. Angles 1, 2, and 3. Okay, so my exterior angles, we can start filling in this chart, will be angles 1, 2, and 3. Everyone see them? Identify them. All right, I need a new vocabulary term here for you. Not coming up yet, but all right, let's start with angle 1. Everyone look at angle 1, that exterior angle. What is the adjacent interior angle to it? The adjacent, so adjacent next to interior. Emma, what do you think?
Angle A.
Lowercase a, yep. Angle lowercase a, yep. All right, now I want to give a name to the other two interior angles that aren't next to 1. Okay, the other two interior angles that are not next to angle 1, we're going to start referring to them as, I like this term the best, remote interior. Remote interior. Those are the two interior angles not next to my exterior one. So what would be the case here? What are the two interior ones for angle 1 that are not next to angle 1? It would be angle B and C. Yep, B and C. They're not. They're inside, but they're not next to angle 1. So that would be B and C for angle 1. Can you and your group fill in the rest of the chart for exterior angle 2 and exterior angle 3 right now, real quick? Go ahead. All right, what's next to angle 2? What angle's next to angle 2? Romeo?
Angle B.
Angle B. So the remote interior angles for angle 2 would be A and C. Yep. Remote interior. The two angles not next to the exterior one. And then finally, the angle next to angle 3 would be angle C with the remote interior angles A and B. All right. I'm showing you this because you and your group right now are going to come up with a relationship. There is a relationship between an exterior angle and its remote interiors. There's a relationship, and you and your group are going to find that right now. You should have a little white space off to the right next to this diagram here. I'm going to have you draw 2 triangles right now for me, please. 2 triangles. Not drawing the scale. And that's a straight line, sorry. Here's what I want you to do in your group right now. Find the missing angles of both triangles. Okay, find the missing angles. And then after you do that, see if you can find a relationship between the exterior angle I gave you and the 2 remote interiors after you find the missing angles. All right, go ahead. Find the missing angles in your group right now. And then ask yourself and your group, hey, what's the relationship between the exterior angle he gave us and the 2 remote interiors? There should be a relationship. Let's find it. Find the missing angles. Look at the exterior of one triangle and the remote interior. See if there's a relationship.
Which one would it be?
Would it be?
Could be a Let me just see if I'm good.
Yeah.
So, but not on this one.
Mm-mm.
Sorry, what?
Oh yeah, you're right.
Adding words to
What are the interior angle for 120 is 60. Maybe supplementary.
yeah. Because it's like 3 of them shown. And then it'd be 120 up top. Could be 20 there.
Can we find a pattern?
Where would the 80 here? If all the angles were whole, one of these
But it's just big.
Maybe something? Maybe? Nothing? You look at the exterior angle right now. So 120 and the 2 remote interior angles, 40 and the one you found. There's got to be something between them. You got to look at 160 and 100 and the other remote interior you found. They got to be something. I'll get back to you guys in 1 second. Let me write down the angles first. What's next to the 120? 60, right? What's the third angle then? Oh, wait, your remote interiors were 80 and 40 and your exterior was 120? There's not a relationship there? Let's keep going. What's next to 160? 20. What's the other missing angle then?
60.
Is there a relationship between 160, the exterior I gave you, and the 2 remotes? 120 and the 2 remotes? How do you find an exterior angle? An exterior angle is always equal to what? Go ahead. The 2 remotes what? Added together. That's always the case. Exterior angle is always equal to the 2 remotes added together. So here you go. Here's our theorem. What you guys just told me. An exterior angle is always equal to, I'm not going to say 2 remotes added up. What do you call the answer when you add? Sum of the 2 remote interiors. There you go. Good job finding it. Good job. So that's what we're going to carry with us for the rest of today in this unit. Exterior is equal to the sum of the 2 remotes. All right, let's see what you got in you now. Okay, angle X, what type of angle is it? Where is it? What type of angle is X? Outside, so it's exterior. So I'm like, oh, no problem. I know an exterior is equal to the sum of the 2 remotes. What are the 2 remote measures? 40 and 90. We're done. 130. Done. All right. Not bad, right? Not bad. Oh boy. Hey, you better buckle up right now. Buckle up. All right, because it's going to get a little chaotic, for example, too. Go ahead, label your diagram. Go ahead, I'll let you label everything. It's going to get a little chaotic here. Oh, I knew this was going to happen. You got x squared minus 6x here. Everyone's good? You got 2x minus 3 here. Nobody's having any issues. And here's the issue. Where is ACD? Please follow the letters. Where's ACD? ACD, anybody? Where is it, Via?
It's at angle C right there.
Well, let's use our words. Interior, exterior.
Interior.
It is?
Wait.
ACB's interior, but not ACD.
Oh, sorry, ACD
That's what I looked when I saw walking around here. Hey, ACD. ACD is right here. It's not inside the triangle, ladies and gentlemen. Not inside. Follow the letters, right? ACD brings you outside. ACB would bring you inside. All right, so let's use our new theorem. Which one's the exterior angle up here? 9x plus 27. How do I find an exterior angle again? Here we go. What do you got for me? 23. Which are what here, Lucy? There you go. There's what we just wrote down. Exterior angle equals the sum of the two remotes. Now the question is, how the heck do I solve it? This is where it gets chaotic. Can we at least clean up the right side a little bit? Can you clean? What do I mean by clean it up? What can you still do on the right side? Negative 6x and 2x. Can you combine those for me? All right, I'm not even screwing around here. I'm just going to get right after it. Anybody know what's going to end up happening here when I have to solve for x? Scott? Yeah, darn right. Hey, everybody, ready? Hi, I'm x squared. That automatically tells me if I got an x squared and I got to solve for x, it's factor time. As devastating as that may be, okay, I warned you guys last unit, it's coming back. So I see an x squared, I'm going to have to factor. Not right now, though.
Yeah, because
Not right now. When am I allowed to factor, Via?
it's only when the other side is 0.
One side is 0, right?
Yeah, when one side is 0.
One side 0. Right now, is my x squared positive or negative?
Positive.
It's positive. Keep it that way. So don't touch anything on the right. Let's move 9x and 27 over. Again, I need one side equal to 0 before you can start thinking about factoring. How do I move the 9x over? Here we go. 22. How do I move the 9x over?
You subtract 9x.
Subtract 9x. So I'll have 27 equals x squared. What am I going to have on this side when I subtract 9x? I'm asking even the simple questions. 10? Josh? Good. Minus 13x. Minus 3. I still need to get the 27 over, though. It's not equal to 0 yet. How do I get the 27 over? 16? Subtract it. Good. Now it's equal to 0. X squared minus 13x. And then what happens when I subtract 27 over? What new number do I get there? Even the simple questions. 18 minus 30. There it is. Please make sure it's equal to 0. All right, here comes the factoring part. I'll slow down now. Anybody have any issues me getting it equal to 0 and why I got negative 13 and negative 30? All right, let's slow it down. Now it's time to factor. And this is the only type of factoring I'm going to ask out of you. You have two parentheses, if you remember from last year. And the first two spots are always going to be what? X and X to give you X squared. Okay, that's always going to be consistent. All right, now you got to play a little game, right? Two numbers. I got to think of two numbers that do two things. Anybody, what should I know about these two numbers? One thing, Emma. Good. Negative. Which one up here does it have to multiply to?
30.
Negative 30. Good. It's got to multiply to negative 30, but at the same time, those two numbers have to, Scott? Add to negative 13. Correct. So this is where you got to put in some work. I always start with the numbers that multiply. That's the easiest way. Give me numbers that think about numbers in your head that multiply to 30 that possibly could give you a 13 somehow. All right, so think of some numbers in your head that multiply to 30, but then you say, oh wait, yeah, those numbers can give me 13 if I played around a little bit. Anybody have a pair that right off the bat that multiply to 30 that possibly could get 13 from? Romeo?
15 and negative 15 and positive 2.
15 and 2? Hold on. Many of you might have thought 10 and 3. Let me just write that down, even though it's incorrect. And I don't blame you, because you could get How, here, ready? How could I get negative 13 from that? If I put what signs in front? How could I get 10 and 3 to add to a negative 13? If they're both negative, right? But anybody want to tell me why that won't work? Jackson? That's a positive 30, not negative. That's why 10 and 3 won't work. So yes, I'm going to have to go with Romeo's 15 and 2. Those are the other pair that could give me 13. And what signs? I remember add to negative 13. So the 15's got to be negative and the 2. All right, that's the only type of factoring I'm going to have you guys do for now. All right, only type. Multiply to this, add to this. Are we done? I need x equals, right? I need x equals. So what am I going to do to each parenthesis? Set it equal to 0. So x minus 15 equals 0. What's your value of x here? If I solve for x equals positive 15. And then what about over here? X equals negative 2. Now we're going to have an awkward staring contest because I still have a problem. Anybody? Got a problem? Think you know what my problem is, Via? Go ahead and try
We
it.
still need to find the angle measurements.
What's it say in the directions? What's the value of x? So I don't have to plug it back in.
Oh,
Right?
there's 2 x's. Yeah.
What's that?
There's 2 x's.
Okay. So I'm still listening.
So one of them has to. So it's probably one of them has to be right.
You think? You're on the right track. I just need a mathematical. And ready? Take negative 2, everyone. We got an answer of negative 2, right? I want you to go back up to your diagram and plug negative 2 in for B, angle B. Anybody have a problem with what they get? If you take negative 2 and plug it in for angle B, what's your problem? Angle B is going to be what?
Negative number.
Negative degree measure? We don't roll like that. Can't have a negative degree measure. All right? So negative 2 can't be an answer, not because it's negative, but because when I plugged it in, what happened? You get a negative degree. Okay? If I plug 15 in anywhere, I'm always going to get a positive degree. Does everyone see why I'm about to reject negative 2? Not because it's negative, because it gives me a negative angle. That's a problem. All right, so we're going to take negative 2, and fellas, like some of the stories of your life, rejected. All right, too harsh, sorry. All good? Are we okay? Why I'm rejecting negative 2? Not because it's negative, because it gives me a negative angle. You and your group right now, you got the last one. All right, you got the last one right now. With parallel lines. Ooh, this should be a good one. We got a couple minutes left in the period. I'm just gonna jot the answers down up here so you can check them when you're done. You and your group. Ooh, parallel lines. Got some angles working. Special angles, maybe. Try to think of angles formed by parallel lines from last unit. Supplementary angles, linear pairs, 180 degrees of a triangle. However you can get there. Even if it means putting in an angle you don't need. Okay, maybe you find an angle you don't need, but it'll lead to one of the answers.
So that's 44. What was that?
This is an angle, not
So
very
it's gonna be Y and 90, and then like the two opposites, you know, that, yeah. Oh, whatever, I'm close.
So BPZ, or PP, 136 or something.
Yeah, 136.
Also CRT is also.
That's all we do. Find RQIs.
Well, isn't PRS correspondence to?
Yeah, I got that.
If you have to find an angle that's not S, find it, it may help you. Again, I'm just gonna ask people to come on in if you're having trouble.
Is this 126?
You got 2 more grades left, 2 more big grades left, first quarter.
Have a good day.
See you guys.
Thank you.